In the last video, we went through how you will generate the key matrix that is central to how the Playfair Cipher works. You can see here this 5 by 5 matrix, how you can generate it in code when given a string as a key. And we went to the code for that. What I did after that was turn it into its own function, right? So then you could always call this function to generate the key matrix by sending in a string. And that's just a way to help clean up the code a little bit. Now that we have generated the key matrix, let's then move on to the encryption. So for the Playfair ciphers, there are 4 rules that are listed on the Wikipedia page, and I've pasted it here. Rule 1, if first split the string up into pairs of letters, and if both letters are the same, or if there's only one letter left, we are going to add an X after the first letter. After that, rule 2 is if the letters appear on the same row in your table as such, right? Then we're going to replace it with the letters to their immediate right, and we are going to shift back, wrap back to the left if need be. Rule number 3, if the letters are on the same column, then pick the letters immediately below them and wrap to the top if need be. And the last scenario is they are not in the same row and not in the same column, there will be something like this. You can sort of create a rectangular box to bound the two letters. They will form like two opposing corners of a rectangle, and then we'll use we'll pick the other two letters that form the other two corners as the encrypted pair. Right, so let's start off first with rule number 1. We are going to have to go through every pair of letters and then check if they're the same letter. In this case, I think the EE is going to be the same. It's going to be repeated, and they're going to be in the same pair. So we're going to see that it applies there, and also we're going to see that there will be one letter left. P will not have a pair, and so we want to make sure that we pair it up with the letter X. Okay. So in order to do that, we are not going to go through every single character in the string using something like a for character in plain text. Instead, we're going to use an index, right? And that index is going to help us go through every single character in the plain text string, but at the same time, it will allow us to maybe jump like 2 characters, and sometimes, and then if there is a repeat, it will allow us to have greater control over like maybe jumping over just one character instead, right? So we are going to use a numerical index rather than picking up every character from the plain text in order. So we will then say like for I in range of length of our plain text, right? So we will have our 2 letters. So let's say our first character will assign it to perhaps let's say A, right? A would be, we'll grab out the first letter from the plain text, and then B will be the second letter from the plain text. So when we do this, we got to be sure that there is a second letter, right? So if it happens that we end up with P, one character left, there is no second character after that, right? So we have to do a check that that's not the case. And if that's the case, then we want to make sure that we add a b is actually going to be x instead, right? So we will do a conditional check if I plus 1, right, is actually the length of the plain text, right? So which means that if you have actually gone beyond uh, the last character of the string, uh, we are actually going to put b to be the character x, right? And in this case, I'm actually going to have initialize b to be empty first. So if we are going past the last character on the string, we are going to add the letter b x there at the end. Otherwise, it will be the second character, right? So that will apply the last character, one letter left rule, and we also want to make sure that we the both letters are not the same. Oh, okay, I see. It starts to get a little bit more complicated as I think about it, but never mind. It will work for this scenario. I will explain later where I'm getting into a little bit of trouble. But we also want to make sure that A and B are not the same, right? If A not equal to B, right, then we are fine. We are actually going to append to our plain text pairs the character A and B together, and we are going to move our index by 2 steps over. Okay. Otherwise, A is equal to B, and what we are going to do is we are then just going to append A and the letter X, and we're just going to move over by 1. And here I can see that I actually can't use a for loop. I'm actually going to go use a while loop instead. While I is less than the length of the plain text, right? So this loop is going to, because we have no idea how many times this is going to run. So we'll use a while loop instead, because we have no idea how many times we're going to apply that rule 1 there. Okay. And so we've done that. Let's print out our plain text pairs to see what we get. Okay. And let's take a look at here. Hide the gold in T in INT NTHETREXESTUMP, right? It looks correct. Actually, we did not hit the last character. So I'm gonna add, let's say the letter F here, just to make sure that we hit that code. Right, so if there was one last character left, you will add an X to it at the end, and we see that here to become FX. Okay, so I think our rule 1 application works, and I just want to mention what I was thinking about. There is a problem, I think, if the end of our thing is is the letter X, right? Because then there's going to be many. We are going to reach this situation where we are going to get XX here. And when that happens, the whole point of rule number 1 is so that we don't have the same letter appear in a pair, right? So you don't get LL, and we are not supposed to get XX because we have no idea what rule to apply for that, right? So there's something wrong in our code here, but this is probably very unlikely scenario, and just to keep the code simple, we are not gonna address that possibility of this scenario happening.